Welcome, everybody. We're going to go ahead and get started here. First and foremost, my name is Jacob Smith. I am the Community Director for Altimetrik Collider Detroit, which I'll explain in just a moment. Joined by my esteemed right hand, Ryan Robinson. Don't know where she is on your screen, but say hi to the people,
I'm
Ryan.
here, Jacob.
Oh, beautiful.
Hey there.
And yeah, we're really excited to have everybody. Today we are talking about data engineering in the real world. So we're going to get into that in just a moment, but as a point of introduction and letting everybody know kind of who we are. So Altimetrik, we're hosting today's session. Altimetrik is a digital transformation company, actually headquartered in Southfield, Michigan, with a global presence. So what digital transformation essentially means is that we help companies stay ahead of the curve with the ever-changing landscape of technology. So as companies grow, they're looking to keep up, and we help them stay ahead of the curve and drive innovation from within their teams. So Ryan and I represent a project within the Altimetrik team called Collider. I see some familiar faces, so some of you know who we are, but essentially the Collider project is the community-facing branch of Altimetrik. So we're serving, to start, the Detroit technology community. With COVID, that has really, we're shifting to strong focus on virtual content, so really kind of available to anybody everywhere, but with a heavy focus on the Detroit area. Really looking to drive, build community within the tech ecosystem between software professionals. So we are here to help you connect to like-minded people, to grow, to learn, and to just be a better software engineer yourself, and also to connect and grow the whole ecosystem. So that's what we exist to do. That looks like a lot of different things. A lot of it is exciting, virtual programming like this. So tech talks, workshops, different things of that nature. So we encourage everybody, if you're tuning in on YouTube, be sure to subscribe. You can find us on social media at Collider Detroit on a variety of channels, and definitely looking forward to keeping in touch. We have a great e-newsletter with tech news updates and upcoming events and all sorts of things. So we encourage you to connect with us and be in touch. We'll drop links in the chat here in a moment. So getting right to the topic here, we're talking about data engineering in the real world. So covering just kind of a brief introduction to what is data science, and then diving into a real world application of what this really looks like for someone doing this every day. So we're joined by Altimetrik team member Ilangovan, Lango, Sathasivan. I screwed that up anyways, I'm sorry, Lango.
You're close, you're close.
So anyhow, so Lango is a data engineer. Again, he works on the Altimetrik team, working full-time at Ford Motor Company on the data fulfillment application team. So Lango is an extremely experienced software engineer with 8+ years of experience in Hadoop and big data. So he is an expert in this area. He really knows what he's talking about. And we are very excited to hear what he has to say. So with that, I'm going to turn it over to Lango to explain what we're talking about in a bit more detail.
Sure. Thank you, Jacob, for the brief introduction. Hello, everyone. I'm Ilangovan Sathasivan. So as Jacob just said, I'm working in Altimetrik for last 1 year, and I'm working as a data engineer at Ford Motor Company. So today we'll be looking at the few topics. So these are the agendas. So I'll go over a little bit about data science and what it is about, and then we'll dive into data engineers, what they do, what's their roles and responsibilities, and how their day-to-day tasks will look like, and then how data engineers at Ford differ from other data engineers' usual roles, and what are some of the tools and technologies for data engineers in common. And so data engineering for Java developers is one of the topic where I picked up. So we will touch some information about that, and we'll see a sample Hadoop project to give you a taste of how the Hadoop project in real time will be looking like, and then we will end up with few Q&As, and I'll give you some reference of where to start and how to shine in data engineering if you are not a data engineer already. So let's start with what is data science. Okay. So data science. So due to the digital transformation, so every company in the world, they are producing huge amount of new types and more complicated data, and they are producing it at very high frequency. Now we have the comfort of collecting all that data and have that in somewhere, and then we can produce some meaningful insights out of that. So what data science is all about? So it is about extracting, analyzing, visualizing, and managing the data, and create some insights from that. So what these insights will help? So this will help to make powerful data-driven decisions. It's all about proven data. So whatever decisions any company take, they can take with the full authority, because they are taking the decisions based on some proven data-driven decisions. So again, data science is the most important tools in currently to understand the world, like how what people thinks, like how is the trend going on, and everything is comes under data science nowadays. In data science, so there are I would say there are two major factors. One is like data engineering and the data scientist. So these two are very significant in any data science projects. So they are making they are making ready for the any company to make any decisions based on the data and the analysis what they do. So what is the advantage of data science? It is used for better marketing, and they can do the customer acquisition and the retention and all that, and it's one of the key in innovation industry as well, the data science. Overall, if you see, it has three stages, data science. If you see, there are data engineering and analytics and the delivery. So data engineering, we have three important steps in there. That is collecting the data and ingesting it into some data lake or data warehouse, and how you prepare that data. And that's all the major role for data engineers. There is another major team called analytics, where they do the computation and the machine learning to use the data collected by the data engineers, and they'll also present that data into a meaningful manner to any business users or any non-technical users, so that they can take any decisions. So this is kind of a repetitive, like we keep collecting the data, and we keep ingesting that, and we prepare the data, and some analytics keep being run on the data, and then they keep presenting that to the users or the company, so that they will be able to take any decisions. This is what data science in a nutshell, but it's not like what I have shown here. It's huge than whatever we noticed here. So any questions on this, or shall we proceed for next?
I guess we'll proceed.
Okay, all right. So data engineers. So data engineers, they are laying the groundwork that makes the data science possible, because they are the one who do the groundwork to collect the data and do all those sort of steps. So their roles are like listed here. So they design and develop the data flow between the source systems and the storage systems. So they will talk to the source teams and collect the required data, and they will securely get the data, and then they will store that into some storage systems. There are different types of data available currently. There are semi-structured data, and there are unstructured data and structured data. So how we are getting categorized these semi-structured, like JSON, if you would have heard, JSON is one of the semi-structured, where it's not actually, you will not be able to use it as it is into a table, but you will be able to get the data elements from the JSON, and then you will be able to do that. That's called a semi-structured. So unstructured is like a fixed length text files or something, so where it does not have any structure at all, but you will be able to get the data from that unstructured file into some meaningful tables structure, so that you will be able to run queries on it. And there some data you might get in a structured format itself, where you will be able where you can import the data from some already existing tables, or from Excel or any other different databases. So data engineers usually deal with all these different types of data. They have to write the design and develop the data flow for these different data structures. If it is structured data, they can go A to A, meaning they can just get the data and store that into a table, so that anybody, we can run the queries on that. If it is unstructured, they have to do some cleansing, and they have to do some pre-work to make it usable, and same as a semi-structure. So during the ingestion process, they do clean the data, they do some transformation, and then they consistently process the data into some usable format, where any analytical users or anybody can query the table or something. So they also work in SQL for querying the data, and also implement appropriate data storage solutions. So data storage solutions in the sense, like there are different types of tables and data storage solutions available in Hadoop. You can have a HBase, you can have NoSQL databases, you have Hive database, and all that. So depends on the incoming data, they have to implement appropriate solutions, so that the data will be safely stored and ready to use from any users. And one more role they do is, like, they do the deduplication, and they do verify and enrich data. So what this means is, like, if the source systems are sending, for example, 100 records a day, so they data engineers make sure that they are not sending the same 100 records every time, or something like that, to deduplicate the data and store the appropriate data into the data storage. And sometimes they do enrich the data, meaning so sometimes they will just get the for example, email address as the data element, but they have to query some other system or some other table to get all the first name and last name and other details, and then they will store the data. So this is like enriching the data, whatever. So getting one element and use that element to get more element is for enriching the data. So next is, like, profiling the data for having the quality data shared. So for example, so if we are expecting some of the field or some of the key column should not be null, or it should not be having any wrong data, so they do a profile of that data, and they will check the quality of the data, so that they will be, when they share to data scientists, or when some decision is being taken based on the data, so the data has to be qualify. I mean, it should be on high quality, as well as it should not have any data issues. So another common activity they do is so they build a mechanism to rebuild missing data in case of any source system failure. So if a source system supposed to send like 3 files, they send only 2, and then they did not send the other one. So they will create a mechanism to kind of restart or rerun the failed jobs or something like that. So they do it's also one of the responsibility of them. And one more is like a data retention and archival. Like the source system will send one, I mean, if we purchase data from any outside third parties or somewhere, so we get the data, and then we should store that data for our future use, or if we want to reuse the data for something else. So they also do data retention and archival, so that we will be able to do the history data analysis as well. So these are some of the common activities or roles, or the activities that they do, the data engineers do. So on the right hand side, if you see, I put them in a step where it's all I explained whatever it is. Obviously, there will be more activities. It's depends on the client to clients, but these are some of the common activities that data engineers do across organizations. So moving on to the responsibilities, like additional responsibilities, which I covered earlier. So additional to whatever I told, the activities, so data engineers will also participate in the architecture design. Architecture design, so they work with the solution architects to design the data platform. So how the data is coming, so what are the sources of data, so what frequency they are sending the data, and how we can store, so what will be the storage capacity, and how we are going to process the data. So all the architecture of a data product will be, so the data engineers will be part of it, and or some companies data engineers themselves do the architecture design. Additional to that, they also development of data related tools. So they use their programming skills. So in industry, in Hadoop industry, we have the tools and techniques to do most of the activities, but sometimes such tools or such things will not be there. So based on the requirement, we might need to customize and manage some of the integration tools or databases and systems. So they have to develop such data related tools. So next thing is the data pipeline maintenance and testing. Data engineers do the development of data pipeline, as I said. So they also maintain that data pipeline and do the testing in the development environment. So this is one of the responsibility of data engineers. So data access tools. In some of the organizations, I heard like, so some non-technical users also would like to view the data, and they want to generate some reports out of your data storage or your Hive tables, or if you have any data storage. So in such cases, the data engineers are responsible for providing such reports based on their business requirements, or they will set up some views or something, so that the users or anyone can just use that view to view the data on daily basis. So this is also one of the responsibility of the data engineers. And prototypes and POCs. So data engineers do a lot of prototypes and proof of concepts for any selected solution, and they will demonstrate that to the organization, so that they will be able to achieve, or they will be able to provide some meaningful insight based on the data whichever they receive. So they do a lot of prototypes and proof of concepts. Continuous improvements. This is not common. This is not specific to data engineers. It's very common. So they all as other developers they always up to date with the industry standards and the technological advancements, which will improve the data quality or in any other mechanism. So that's one of the common responsibility of engineers. And data security. So this is one of the key aspect in terms of data engineering responsibilities. So they have to keep the organization's data secured, and they apply data protection and masking of the data as well. So in any organization, they will be handling a lot of personal identifiers or so many account related items and all. So data engineers will be making sure that that data is not uh, it's not leaked or it's not going into the wrong hands. So they will apply appropriate protection on the data, and they will mask the data appropriately whenever that is required. So this data security is also the responsibility of the data engineers. So other than that, they do the technical support and root cause analysis. Again, this is common for everyone. It's not like only data engineers, but data engineers also have to do the feature enhancements or any technical and infrastructure related issues. So they handle the failures and rerun the data pipeline in case if it needed and all that. In case of any failure already happened, and then they do the root cause analysis to identify the opportunities to improve their data product. So these are some of the responsibilities of data engineers. Do we have any questions? I'll pause here for 5 seconds, then we can proceed.
Anybody have any questions? Feel free to just, as we go, drop them right in the chat box, and we'll work them in. So you don't have to worry about that, Lango. I'll let you know.
All right, sure. Okay. So then, so next topic is like so data engineers at Ford. So
hey, Lango, before you move on, somebody snuck in with a question here. So sorry to interrupt you.
Sure.
It looks like Deepak is asking, related to entry-level data engineering, what type of experience do you see in candidates? Do you have insight on kind of technologies and projects that are looked for in a candidate? And then he's asking about types of projects you work on, but Deepak, we'll be getting into that in a little bit here.
Yep. So exactly. So I'll be touching based on the question, but so the entry-level data engineers, I would say plain software developers, like who knows very good on SQLs. So because we do a lot of SQL programming in the data area, and then how to process the data, and the mindset, like how you come from the Java development background or the RDBMS background to a world where we can you have to wait for a query to complete. Sometimes it might take a lot of patience. So so that kind of things are needed. So I'll explain in a moment about like what will be the tools or technologies that will be required for data engineers. So I'm starting with this data engineers at Ford. So every company has a different set of roles assigned for data engineers. So it's kind of overlapping because some companies has plain data engineers. Some companies might have part of data scientist role into data engineers. But I'm going to touch about data engineers at Ford, how it looks like, because I've been here for like an year now. So here, what we are doing, so as I already explained, so we are identifying the data elements for a data product delivery, where Ford even purchase and sell the data to outside companies. So we have to find the data elements. So data product delivery is both incoming and outgoing data. we work with source systems for getting the data transformed into a fulfillment zone where we do a lot of additional transformations to make that data as a sellable data. We work with source systems for getting the data, raw data, into our fulfillment zone. So for that, we create file watchers and data validators and all. So this is one of the additional activity which normally I have not seen anywhere else we are doing this. So this is one of the customized activity we are doing at Ford, where so we do data validation. So even before we start any transformation, once immediately we receive the data from the source systems, we run kind of data validator. So we have created a data validator utility, so where it will accept a few arguments and it will check the data. So it will just check, okay, so the data is so and so format or something like that. So initial data validation is being done. So most of the companies do the data validation at the end of or just before they do the data transfer. But here we are doing it in upfront, so that we are not wasting any resources or time in processing the wrong data or failure data. This is actually, it's not file, it's a file watcher. So we ask the source systems to create some file watchers where they will be providing a kind of a signal where they are ready to send the files for us, the source systems. So that's kind of a signal thing. So we used to get from the source systems. So this one is again same thing as other data engineers. We apply transformations and enrich the data, and we are storing that in Hive. There are backups being taken for the data. So we also have the history Hive table for maintaining the history of data. So this is normal activity of data engineer. So this one is we have created. Ford has a utility for identifying any data anomalies or any data quality issues, and they have created a very nice program for analyzing the data quality. So we have that here. So this I assume that would have been created by some data engineers only. So next thing is we are currently using Spark and Python to process the data and making it ready for use. So the technologies are Spark and Python and Scala. So we are using in Ford. So this is they not only just identify the anomalies, they also report those error to the source systems, and they are aborting the data delivery, so that once the source system rectify their mistakes or errors, so the data delivery will start from the beginning. So they will start from zero to resend the data and everything. So this is one of the thing where someone is paying for the data and they are getting the quality data. So this is one of the additional items I learned from Ford. So this one is again common. So they are so they'll be creating workflows for executing multiple actions sequentially, starting from data load, ingesting, and processing, and sending. Doing FTP and all. So this is again common thing. And so this one, so they do a lot of automation of data ingestion, and they have created a data ingestion framework. So in the data ingestion framework, they have a kind of a plug and play data framework where they will be able to collect data and they accept a few parameters, and then they will just be able to ingest the data in of variety of files into Hadoop. So this is automation is one of the key thing at Ford we are doing. So they also have an alert mechanism where as I already explained. So data quality errors are reported not only to the source systems through the alert mechanism. So the developers or the data engineers are getting to know that. So they will take appropriate action based on the alert system. These are some of the common activities we do at Ford. Again, I'm talking from my project experience. There might be multiple projects at Ford for GDIS space. So it will be much more than that, but this is what I know. We will move on to the next topic. So technologies and tools for data engineers. So Hadoop and the big data technologies are growing every day. So every day they are bringing in new technologies because the open source communities are actively working on some of the projects. And it's been one of the hot topics and technologies for quite some time now. So as a data engineer, so what are the tools or technologies I should be aware of? Or I mean, obviously we will not be able to know everything of this, but so that's why I categorized into few of the things. So at least one of these from any of this would be a good starting point for being a data engineer. So let's start with the data platform. So what is data platform? So there are currently some of the companies like Hortonworks or Cloudera or Mapr. So they are taking care of the cluster, Hadoop cluster, and the storage and the resource allocation and all. So to know any one of these will be a very good starting point. So to understand what they do, how they are managing the cluster, and how they store, and how you can actually implement these in any of our existing systems will be a good starting point. So HTTP and so now Hortonworks and Cloudera they merged actually. So they are going to create a common data platform, but that is not in existence. But so to know to start with, to learn any of these will be a good. So they are providing a kind of a one node cluster, so where you will be able to download from their website to get a feel of like how the Hadoop environment looks like. Next things, database and data warehouse technologies like Hive, HBase, these will be very important for a data engineer role. So these Cassandra and all, it's a NoSQL database, but it's good to have the knowledge of that. And some AWS technologies like Redshift or something also will be a good thing. But any of the database technologies like how you store data and indexing, normalization, and all those techniques will be very good for a data engineer. So next, you must know any of the programming language, either Java, Scala, or any Python will be very good for transforming the data, because the data processing layer, we are using any of these APIs to transform that data into required format. So any one of these programming language will be a good, and then SQL always it's a handy to for data engineers. So data processing. So this nowadays every organization is now moved into Spark processing. So either you are on enterprise data cluster or you are on cloud, doesn't matter. They are using Spark as a in-memory processing of the data. So you have GBs and TBs of data sitting in your storage. You want to process the data and create some meaningful information out of that. So for that, Apache Spark is one of the key technology they are using. So I've seen everywhere they started using Apache Spark. Previously they were using like MapReduce technologies, but once the Apache Spark has come, so it's got very famous. So it's also one of the key technologies to be a data engineer. So on this side, cloud infrastructure. Almost most of the companies started to think about the cloud or already moved into cloud, and some of the companies are already in hybrid mode. Like some of the components they move to cloud, and some of them they have on-premise. In Ford, as far as I know, I think Ford is still on premise, so they have not yet moved to cloud. But to know the cloud infrastructure technologies like AWS or Google Cloud Platform or Azure is very important in these days. After that, we comes the data streaming framework, where we used to get that data real time. So Apache, Kafka, NiFi, or Spark streaming all now is becoming key for a data engineer. And workflow management. So this is how we chain the workflows or the jobs in sequential manner, something like Woozy or Airflow or cron jobs. So these will be important to know. And so the last one, development build tools. So this is not specific to data engineering. This is common for any development, but still it's good to know these tools like Jenkins, how you continuously integrate and continuously build, and any build technologies like Maven or Gradle, and any development experience with Eclipse or IntelliJ IDE will be good plus additional to the Git technologies. So these are some of the key technologies in data engineering role.
Lango, we have a question here in the chat from Hari Krishna. I'm wondering if maybe we want to save this to the end. Just want to check in with you on how you're feeling about timing for the rest of the chat here. We have 20, a little less than 20 minutes remaining.
I think we should be close. So I'll be able to finish it and we will take questions.
Okay, so let's, Hare Krishna, we'll get your question at the top of the Q&A here, at the end here.
Yep. Right. So, so data engineering for Java developers. So why I chose this? So, so onboarding a Java developer is easy considering other skill sets because Java developers naturally ticked a few boxes of data engineering skills already, more than any domain. So that's one of the reasons where a Java developer can easily become a data engineer in no time. So Hadoop is open source and it's a Java-based framework. So it's been written in Java, so it'll be very easy for any Java developer to learn the internals of Hadoop framework itself. So that's one of the key in converting any Java developer to a data engineer. Okay, so if I am a Java developer and I want to maybe start a data engineering role, so what are the things or what are the points I have to consider? So that's what I combined these two into here. So first, to start with Hadoop components. So explore the Hadoop components like what is HDFS, Yarn, Hive, Scoop, and all. So this is all comes under the data distribution, which I shown in the previous slide, like CDH, or if you go anywhere in that, they will start with these wordings like Hive, Scoop, and all. So Hadoop distributions, learn any of these, Cloudera or Hortonworks, so that you will get a feeling of like how they manage and how they actually maintain the Hadoop cluster itself. And it's good to start also the cloud solutions like AWS and Azure and all. After that, so the 3 V's, the volume, variety, and velocity, to understand about the data ingestion. So deep dive into these. So how any organization is generating how much volume or what's the variety and how fast they are producing the data will be a must for understanding the data engineering. After that, how to store the large data. So we are here talking about terabytes and petabytes of data. So how we can store the data, and as you know, Hadoop, you will be storing the Hadoop. By default, it will store 3 copies of whatever the data you store. Like if you store 5 GB of data, so it will store like 15 GB. It will take the overall storage. So learn about storage, and once you store the data, so how will be able to query the data. So for that, you might need to learn the Hive or Spark to read the data. And how Hadoop cluster and all the data we store are fault tolerant, and how we can make it high availability. So that's one of the key point in learning the data engineering skills. And shell scripting and Python programming, as I already told, it's if you already have not done that, it's good to start writing some shell scripts on Python. So there are some real-time data ingestion tools. These are very common tools. They're not sometimes not relevant to only Hadoop. So it's like Kafka is one of the real-time queue where you will be able to deliver and consume the messages in real time. And also some NoSQL databases like as I say, Cassandra, MongoDB, or some of the database technologies will be an add-on. From my personal experience, I was a Java developer like early 2010 or somewhere. So so then when I started learning the Hadoop and data engineering, it was easy for me because of these advantages. Okay, so I want to give an example of a Hadoop project. So where you will be able to think that, okay, how the Hadoop project will be. So here I took an example of auto insurance bills. So where we will be getting our bills in email, and our scope is we also need to send a reminder before 2 days of their due date. So this is our business scenario. So how we can approach this business question or business scenario, or how we can approach this problem. So I divided that into multiple steps. As a data engineer, I divided into multiple steps where I will be able to deliver this insurance bills to the email address, and also I'll send a reminder before 2 days of the due date. So here some of the steps which we can think of is like, one of the steps is like data preparation. So first we can start exploring about what are the key data elements we need for billing, and what will be for the reminders. So here for billing, obviously you need the policy number and a few other details. So we, as a data engineer, we will start writing this all down, and then we will keep enriching this, and we will keep updating this as when necessary. But to start with, so I just started with these basic data elements, where we'll have a policy number, we need to have due date, an amount, and what is the vehicle details, and other details like that. And for reminders, so I need all the above details plus the payments data, because I need to verify before 2 days of their due date that should whatever they need to pay, did they pay or not. So this is how I prepare the data. I mean, the data elements I need to prepare. So next I will start with the data collection. I'll start the conversation with the source systems. So because of this business question or business challenge, so I might be requiring these details. So I might need the access to the database, customer database, vehicle database, payment systems, and billing. So these are the source systems might come into picture when we need to collect the data. So we need to have a conversation with them, and then we collect the data from them. Assuming we collected the data, so next is we have to do the cleaning. Once they provided the data, so we have to, so some of the challenges would be we need to identify if there are any duplicate bills or any canceled policies are there, or there might be any other things, but we need to do some kind of data cleaning before we actually do the data processing. So as a next step, we can start with the data processing. So where we can see, so when I want to, so I have the bill data, so I have to send the email to the consumers. So for what I have to do, so I somehow I need to validate their email address. And if someone is still opted in receiving the bills in email, or they want a mail, and what if someone has multiple email address, should I send email to all of the email address, or so if someone has multiple policies, so should I all combine them into one, and then should I send to one email address? So all these business challenges will be there. So this all will be applied when we do the data processing. So when the data processing is complete, and then when we produce output file, that should be the final result of the list of email address or list of consumers, which we need to send a email under the reminders. Other than that, so we also need to find the data landing. So once we get the data from the source systems, how we securely transfer that, or once you produce the output file, so how you are going to securely transfer to some systems where they will be able to actually compose the email and send. So those we have to, as a data engineer, it's a responsibility of us. And then data flow. So we also need to create workflows to schedule this data pipeline jobs, something like Oozie or any other data flow technologies. And as I said, data processing, it's again, we are using Spark. And so here the data processing, so we might need to do two kind of data processing. One is for maybe if you want to separate, you want to do one data processing for billing and one for reminders, or you can combine both of them into one. It's up to us. But here we are considering that we are in this case, it's again a business decision. Like even if a billing job failed, even if a reminder job failed, I still want to send at least the bills. Not even if I fail to send reminders, it's okay. But if I fail to send a bill, that's not right. So we can have two separate processing for billing and reminders. So we can create another output file for the reminders. And once the file is ready, we can find any data anomalies. Like sometimes when I see there was a bill for like $10,000 or something, so that's obviously wrong. So such kind of data issues you can find by doing some data quality on your output file, which you are about to, before you actually send an email to consumers. So and then once you've done the data quality, you securely transfer to the drop zone, or any of the vendors is processing your files, the reminder files. So this is just a high level steps, but when we actually do such project, it will be more in depth, but this is how we can start with the Hadoop project as a data engineer. So I have few links here which will help all of us to learn further. There are nice documentations out there for Spark, Scale, and other technologies which we discussed. Yeah, so that's all. We can go for the questions.
Yeah, so with the remaining time here, let's dive into some Q&A. So Hari Krishna had asked, so how data platform is different from cloud infrastructure like AWS, since we can create clusters in AWS also. How does CDH or MAPR give advantages?
So initially, when the Hadoop technologies like before the AWS comes into picture, so we started with the commodity machines to create a Hadoop clusters. Like we create our own servers, we maintain that servers, and we will install some Hadoop distributions like CDH and all. So where they will CDH is a kind of a software where we will give like 10 machines. So they will be able to install that software on that. So we will be able to bypass some of the activities like capacity scheduling or some of the technologies. So now, in case if my data is growing, so I am the one who is responsible for adding additional servers. Either I have to take a decision of horizontal growing or vertical growing. All this I have to take care. In case of failures, again I have to take care. Security, the data organization has to take care. So these are all the bottlenecks of having in-premise clusters. But when you come to AWS, it's all being taken care by AWS. So they have the security enabled, they have the servers ready, so they automatically grow up your servers when you started to use large data, and then they automatically shrink the data when the data is not that much. So they also taken so many burdens from in-premise to the AWS. So that's why the most of the companies are now started investing in AWS. So yeah.
Gotcha. And then we've got from Sue V. Who are the stakeholders in an organization that a data engineer typically works with, or I suppose you could add reports to?
So always data engineers work with in hand with the data scientists. So data scientists are the one who actually know the business problem. So so data engineers make the data ready for the data scientists. So they work based on the instructions from the data scientists. So data scientists will get the instruction from the business owners or whoever is on the business roles. Let's say I can give an example. So in Ford, we are doing a project called Team Edison DTE. So it's a project where DTE is an energy company where they want to see the energy stations where you can charge your electric cars. So they want to know where the hub. So they are planning to, let's say they are planning to create another hub in somewhere in Detroit or in Michigan. So they want to know where, which are the areas already the charging is happening. So if this is the business case, then the data scientists will know, okay, so how they can provide a related data to that. So meaning, what are the number of cars or what are the number of days the charging is happening in a particular station, how much energy they charge in for each car, and so all these details will be data scientists will decide, and then the data engineers, so they will collect all the data and then they will just provide in, for example, in a file or in a Hive table, so that they will be able to deliver this data to the DT to, I mean, it's kind of a data product. They will be able to use it.
Great. And then from Harshita, we've got a graduate student majoring in data science, extensively working in Python. So do you suggest that Java be added into that mix, or is a strong foundation in Python good enough?
I would say Python is good. So Python programming. The data scientists also will use majority in the Python programming. But when it comes to data engineers specifically, so PySpark is the one we generally use. So Python is enough, but it won't be sufficient if you want to do some programming in Scala or something, because each APIs like Scala and your Python has some advantages and disadvantages, but either one is good, but not bad to learn Scala or Java.
So backend developer with experience in Java, Spring Boot, AWS, Spark Streaming, and Kafka, thinking about switching to data engineering, wondering, do I need to stick with Java as a main programming language or Python for data engineering? So that looks like a somewhat similar question, but coming from a different angle.
Right. so if Java is already learned, then Scala is pretty simple to learn. So because they are pretty much same kind of syntax and all. So the functional programming world, like even Java has, like after Java 1.8 and all. So it will be easy if to learn Scala if you are a Java developer, and it's not necessary because Spark has come up with 3 APIs. We can write Spark programs in Java, Scala, and Python. So yeah, it's okay. If you know Java, that's fine. If you want to learn Scala, that's good too.
Lango, thank you so much. This was just incredible insight. And yeah, with that, look out for a follow-up for us. Just a reminder to definitely connect with us on social media. Again, subscribe to our YouTube for more awesome updates like this. We're on Meetup, all the above. So with that, I hope everybody enjoys the rest of your Thursdays, and don't be a stranger. We look forward to seeing you soon.
Thanks, everyone.
Thank you, guys. Thank you.